Welcome to my session. My name is Nagaraj. I am from India. I am senior lecturer in mathematics. Today I am going to take a topic, complex numbers. So in this entire session, in this entire topic actually, we'll learn and we will understand how quadratic equations lead to complex numbers and how to plot complex numbers on an Argand diagram. Okay, and we'll be able to relate graphs of polynomials to complex numbers. We'll be able to do basic arithmetic operations on complex numbers which are in the form a plus ib, and we'll understand the polar form, we'll understand Euler's relation and exponential form of the complex number. We'll understand De Moivre's theorem, and we'll interpret relationships of complex numbers. Okay, before beginning this entire session, we'll understand some basics first. Complex numbers. What are complex numbers? Okay, we'll understand. Well, I'll explain you clearly each and every basic definition. Right now, here, if you look at root 9 is a, so this we write as a 3 under root 3 square. That means value is 3. Well, now you please tell me, if I write under root of minus 9 or under root of minus 9, this number is not there in the real system. Okay, so when you take this one as under root of minus 1 into 9, that means root a into root b form, that means root a into root b we can write. So that means what? Root under root minus 1, root 9 value how much? 3, right? Now this number is there in the real system. This number is not existing in the real system, right? For this one, our great mathematicians invented and they kept a name as iota. So this one is iota. That means imaginary numbers. So we can write as 3i. Well, now here, how do we represent this one on the number line? How do we represent this 3i on the number line? Basically, we do not have 3i on the real number system, right? If you look at this one, number line 0, 1, 2, 3 and so on. Okay, and here minus 1, minus 2, minus 3 and so on. Well, any real number we can represent on this real number, near real number line. But where do we represent 3i? So that is the difficulty task. Therefore, our mathematicians invented one more imaginary line. That line is y-axis. This is called imaginary line. Imaginary line. This is real. This is a real line. That is x-axis. Well, this is y-axis. Okay. Now, here when you take a I, first one, 2i, second one, 3i, third one, and so many, 4i, 5, and so on. Okay. Similarly, down, minus I, minus 2i, minus 3i, and so on. Okay. Clear? Now we have represented a 3i on the number line, not on the number line. This is another line. Okay. This entire system is called Argand plane. What do you call? Argand plane. In this Argand plane, we can represent complex numbers. Well, let us understand the definition of complex numbers now. Any number which is in the form of any number which is in the form form a plus ib is called a complex number. Complex number is denoted by z, that means z equal to a plus ib, a plus ib, right? Now, what are a and b? A comma b are real numbers, right? So this is the main definition of a complex number. Okay. Now, how do we represent complex number on the Argand plane? Very well. Let us see one example for a complex number. Here, for example, 2 plus 3i. Okay. So how do we represent, or how do we plot 2 plus 3i on the Argand plane? Well, this is the real number, this is the imaginary part. Okay, so real part is how much? 2 and imaginary part will be 3, right? So intersection of this point, this part is called z, that means 2 plus 3i. Okay, now we know how to plot a complex number on the Argand plane. Well, now next we'll see entire number system. Here we have been studying from childhood natural numbers, whole numbers, integers, rational numbers. Okay, these all together downwards all rational numbers. So rational numbers and irrational numbers, enter this all together we call real numbers, right? Now what is added extra? Complex numbers also added, x plus iy. So complex numbers also added, x plus iy. You can say all the real numbers are subset are equal to complex numbers. I'm just writing complex numbers. Here all the real numbers can be complex numbers, but every complex numbers need not be a real number. This is important note. Well, now power of iota. Okay, so what is power of iota? Basically I means under root of -1, I power 2 under root of -1 whole power 2. That means root under root, this will be getting cancelled, so -1 I to the power of 3. That means what can we write? I square into I. Yes, I can write. So I square means I am replacing with -1 into I. So what do we get? -1 into I, minus I. Next, we will see one interesting pattern over here after finishing I4. I power 4, I am writing as I power 2 into I power 2. So you know very well I power 2 means how much? -1. That means -1 into -1. What does it mean? Minus of minus plus 1 into 1 more. So I to the power of 4 means how much? -1. I to the power of 4 equals to 1. Okay. So I to the power of 5, I to the power of 6, I to the power of 7, I to the power of 8, so on. Whatever you take, you will see one interesting pattern. It will repeat. I power 5 means I power 4 into I. I power 5 if you want. That means what? I power 4 into I. That means what? I power 4 1 into I. You can see first one is repeating or not. I power 6 means again you will see I square value. I power same, similarly you will be repeating. You will be getting a repetition. Now I'll ask you one example here. What is I to the power of 10 value? Well, here I'll tell you one important note. I to the power of 4 into some k, in this formation any number is there, the value is 1. The value is 1. The help of this one, you can write any I to the power of any value, right? Now we can say I to the power of 10. I to the power of 10 means what? How will you write in terms of 4 multiplies? I just write 10 divided by 4. What is the remainder? Get 4 2 is 8. What is the remainder? 2 is the remainder. I just write 4 2 is 4 into 2 plus 2. Okay. Now this means what? I to the power of 4 into 2 into I to the power of 2. Right? Now I to the power of 4 into 2 means any multiple of 4, the value will be 1. Just now we have discussed. I square means what? We can see I square means minus 1. Right? Minus 1. Alright? Just substitute here minus 1. Therefore 1 into minus 1 minus 1. Similarly, you can write any kind of iota value. Right? Hope you are understood. Next, we will discuss modulus. What is a modulus? What is modulus? What is amplitude, argument, conjugate, additive inverse, multiplicative inverse, polar form, Euler form, and arithmetic operations of the numbers. Right? Modulus. First, we'll see about modulus. Modulus of a number. Very simple. Modulus of a number means if g equals to something a plus ib, then modulus of g will be equals to under root of a square plus b square. Okay, this is what modulus of a complex number. Right? Well, we'll see the remaining topics in the next session. Until then, have a great day.